Regardless of your position in the military, you will be susceptible to inaccurate information regarding lasers. Just as in our first video of the laser safety series titled Laser Wars, Corporal Podansky and PFC Washington wrongly thought that the green lasers they performed their Star Wars comedy act with couldn't harm anybody. You too might be willing to trust the comment or opinion of a battle buddy or someone else who appears to be in the know but who couldn't be more wrong. This presentation is for your benefit, to destroy the myths that most commonly run through the ranks of our soldiers and military civilians. The worst myths only make a short list, but this list could mean disaster for you or someone else. Let's test your knowledge as we investigate each one. Sunglasses are a form of laser eye protection, or personal protective equipment. It's a myth, and a very dangerous one. Sunglasses offer no eye protection against lasers, no matter what anybody tells you. People think that face shields, sunglasses, and welding masks can protect their eyes from lasers, but they are so wrong. All lasers operate at very specific wavelengths, or colors. You can see some of them, and others are invisible to your eyes. So, if your laser eye protection doesn't stop a specific laser's wavelength, then you're a target for being injured or blinded. This can be shown in the laboratory. You're looking at a variety of lasers with common visible wavelengths. Each produces a specific color. Yet, no single laser eye protection will block them all. If we insert random laser eye protection into the beam, you can see how it blocks out only a specific laser. But what happens if we try using polarized sunglasses? Notice that in spite of a darker image, none of the beams are stopped from projecting through onto the wall. This means every one of these lasers will hit you in the eye. Now, watch as a pilot's visor is placed in front of them. Again, there's a darker image, but none of the beams are stopped from projecting through. Same thing with a welder's helmet placed in front of these beams. There's a darker image, but none are blocked from shooting through to the wall. So, since none of these unauthorized LEP can block the lasers, the undeniable fact is this. If you need LEP for a training exercise, it will be issued to you in advance, and it will provide you protection from whatever laser is being operated during that exercise. For non-military lasers, check the operator's manual for your laser eye protection requirements. So, don't assume you can protect yourself with your own concoction for LEP. It won't work, and you don't want to prove it by being wrong. If I can't see the beam, then it can't hurt me. It's a myth, and just as dangerous. The military, as well as many civilian operations, make use of high-powered lasers that are invisible to the human eye. These are called IR lasers, short for infrared. In the military, IR lasers can be some of the most powerful available. All you need to know is that many of these invisible lasers pose a devastating physical threat to your eyes. Consider this device. This is a carbon dioxide or CO2 laser. It has an invisible beam. However, turn it on and its effects are readily visible. Notice the burn spot it's making in the firebrick after only a few seconds. This type of laser could be catastrophic if aimed at you. That becomes evident when the firebrick is removed. Those safety glasses have no protective barrier between them and the invisible beam. Imagine what that would do to your eye. Currently, the military isn't operating CO2 lasers for combat training, but it is using target designators, which are invisible Class 4 lasers. their potential for injury is depicted in a different way, using this lab setup to simulate the beam hitting your eye. The lens and test tube seen here represent your eye being struck by an invisible Class 4 laser. The beam will be directed from an off-camera source through a glass lens that simulates the front of your eye. The beam is next focused by the lens onto the bottom of a test tube inside a beaker of water that simulates the water-like interior of your eyeball. The test tube contains red food dye, symbolic of the blood flowing through the blood vessels in your eye. The animated eyeball shows the orientation of the eye for the demonstration. The bottom of the test tube represents the back of the eye at the retina, the part of the eye responsible for vision. What's going to happen is that the amount of energy or heat this laser beam creates will instantly fracture the bottom of the test tube, releasing the red food dye into the beaker. That dye represents the blood that would flow into your eyeball once the blood vessels in your retina popped from that heat. When the arrows reappear, that will indicate when the laser is switched on. The invisible Class 4 beam works so fast that we can't even slow down the footage to illuminate what actually happened at the moment of contact. But in just 20 nanoseconds, the Class 4 laser concentrated enough energy at the retina to burst the blood vessels and severely damage the retina and your vision. That's 20 nanoseconds. It takes about a quarter of a second to blink your eye, so there's no way you can blink or close your eye faster than this laser. In fact, it happens so fast, we could redo this experiment and break over 12 million test tubes before you could blink and look away. So never believe that just because you don't see a laser, it can't hurt you. You couldn't be more wrong. Lasers are just like flashlights and can't harm me. It's a myth. This is a typical military illuminator, housing both a laser illuminator and a laser pointer. You may be issued one in the course of your duties, but that illuminator is not to replace a standard flashlight. Although the IR beam spreads out like a flashlight, it is still a hazardous laser that can only be seen using night vision goggles. So, just because it is a handheld device similar to a flashlight, and because you use it to illuminate targets, doesn't mean you can treat it like a common flashlight. Because of the unique properties of laser light, the eye can concentrate a laser beam far more than a flashlight beam. Consequently, some illuminators have the ability to seriously harm or blind you. So, unless you've been issued specific laser eye protection for an illuminator, you should assume anyone caught in its beam within its prescribed NOHD can be injured, perhaps permanently. For those of you unfamiliar with NOHD, it stands for Nominal Ocular Hazard Distance, the absolute minimum safe distance between you and the laser, where the laser cannot harm your eyes. It's easiest to think of NOHD this way. Ocular means eye. Nominal is the shortest distance to your eye. Hazard distance is where the laser's contact can no longer harm you. So, the NOHD is the point where you are out of a laser's hazard range. There are currently 7 classes of lasers, and every laser above Class 1 and 2 has a NOHD, but you still could be safe from every one of these lasers somewhere. It's a fact. Every laser has a distance where you can be safe, even if you are in its direct beam. That point is the NOHD. But every NOHD is specific to each laser. The only way to be safe is to absolutely know the NOHD of the laser that you are operating, and not point it at personnel that may be within that distance. So, just because your laser pointer or illuminator is the size of a flashlight doesn't mean it's as safe as a flashlight. Lasers are to be treated like weapons. It's as simple as that. You don't point a weapon at just anyone or anything. Likewise, you don't point a laser at just anyone or anything. You must have total familiarity with the laser you've been issued before you know for sure who or what it can be pointed at. And knowledge of the NOHD for all lasers issued to you is imperative. This is explained in more detail by looking at the next issue on the list. Lasers with short NOHDs are safer than lasers with long NOHDs. It's a myth. You will most likely operate lasers with long and short NOHDs. Total understanding of which is in use is paramount to safe laser training. Follow your training and you will always be notified of what laser is in use and where it is being fired. In training, you only laze authorized targets and only in the direction your training calls for. Otherwise, you don't know where your laser is going, who is in its path, and if unprotected personnel are within the NOHD. So, play it safe at all times with any laser. But back to our myth. Are lasers with short NOHDs really safer than lasers with long NOHDs? Operationally, green lasers are currently being used for short distance work, like at vehicle checkpoints and for crowd control, whereas many IR beam lasers are for long distance work, covert pointing and elimination of targets. So it makes sense that those lasers for short distance work have short NOHDs, and those for long distance work have long NOHDs. But a short NOHD green laser could possibly present far more danger than a long NOHD IR laser, especially when it's set to the tactical mode instead of training mode. In tactical, the power is increased significantly, and that poses hazards for everyone around you. As seen earlier, there are 7 classes of lasers, and the higher the class, the more dangerous they become. Any laser referred to as Class 1 is eye safe. It cannot hurt you. Therefore, it has no NOHD. Class 2 is limited to visible wavelengths. They're very bright to look at, but not hazardous. Get above Class 2 and you'd better know what you're dealing with. Let's compare the hazards of 2 widely used Class 3B lasers in tactical mode. A green beam laser and an IR laser, both of which are used for targeting. Something that's not readily apparent just by looking at any laser beam, visible or IR, is how much above or below the Class 1 eye-safe exposure limit it is. For our comparison, the power coming out of the green beam at the laser exit aperture is 520 times above the Class 1 limit. The power coming out of the IR beam at the laser exit aperture is 37 times above the Class 1 exposure limit. So the green laser is 14 times more hazardous than the IR laser, and yet the green laser has the shorter NOHD. How can that be? When looking at these 2 beams, there's no obvious difference other than their color. The green beam appears brighter, but that's only because we see green better than any other color. Up close, the beams are similar in size. But as the beams move downrange, the green beam rapidly grows larger, dispersing its energy in a wider and wider pattern. Not so with the IR beam, which doesn't appear to change much. Downrange, as they strike the wall in the distance, the green beam is now noticeably larger than the IR beam, spreading out in a wider circle. This spreading of the beam over distance is called its divergence, and is one of the characteristics of a laser used to determine its NOHD. Remember the meaning of NOHD, the absolute minimum safe distance between you and the laser where the laser cannot harm your eyes. Consequently, standing in front of any laser at its NOHD point means you're safe. In other words, the green laser aimed at this soldier drops from a high-powered Class 3B laser to an eye-safe Class 1 laser at the NOHD of 32 meters and beyond. Stated another way, the amount of laser power or energy capable of entering your eye once you reach this particular NOHD is equal to or less than the energy from a Class 1 laser. But of course, that distance varies with every laser, and you would never be able to guess where the NOHD is without knowing the laser being used in your particular instance. Hence the need for labeling lasers with their class and individual NOHD. But that's how a laser with a short NOHD can be more hazardous than a laser with a long NOHD. It's all about the energy entering your pupil and the divergence of the laser itself. Your eye collects light through your pupil, the black area in the center of your eye, about the size of a pea. And up close, this Class 3B red beam laser is still very small in diameter as it strikes the eye. Consequently, most, if not all, the energy in this beam is entering the equally small opening of the pupil, so the possibility for injury is very high. It may be a technicality, but it's important to understand that distance from a laser does not change its output power or energy. But because of divergence, that power or energy is spread out as the beam gets larger. So, it is the divergence of the beam that reduces the amount of energy that can pass through your pupil to your retina. This is the biggest factor as to why a laser becomes safer with distance. And as you can see, the green beam is larger. Therefore, some of its energy is striking outside the pupil, on the cornea, the eyelid, and the face. The possibility for injury from the green beam at this distance is much less than at closer distances because the energy has spread out. So, at this particular point, the red beam is likely to be much more hazardous. Remember, with distance, the beam size grows larger, reducing the energy that can enter your eye, which reduces the harm it can cause. You just can't squeeze all that energy through the size of your pupil when the beam is so much larger. However, it bears repeating that any exposure above the safe limit is unacceptable. Just because less energy is entering this soldier's pupil doesn't automatically make it safe. You would have to be beyond the NOHD point for that to happen, but in this example, it is less dangerous at this particular point than the IR laser. So, based on this example, it's a fact that the long NOHD IR laser is not nearly as hazardous as the short NOHD green laser. But face it, as laser operators, you're not going to know how many times above Class 1 your laser is at any given point within the NOHD. But it's also something you should never have to worry about. However, you do need to know the class of laser you're operating and the hazards for any laser within that class. And you have to know the NOHD for your laser and not to laze targets within that range unless you are directed to. So now you know that just because a laser has a short NOHD doesn't mean it's necessarily safer than a laser with a long NOHD. It's best to remember that if a laser has a NOHD at all, then it's dangerous, no matter what the distance is. That's your best protection. The larger the size of the laser, the bigger the hazard. It's a myth. Don't let the size of a laser's housing fool you. Its size doesn't matter. What matters is its class and NOHD. In fact, one could argue that the only thing that does matter is the NOHD, and knowing not to intentionally expose anyone within that distance. A Class 4 laser is the most dangerous class at the present time. Class 4 lasers are utilized in target designators, which often have a very long NOHD. You may come into contact with one in training and combat. However, some have been reduced in size for special operations, so that an individual can carry one that looks very much like a 9mm pistol, but it's still a Class 4 laser and can inflict serious injury if caught in its beam. And vice versa, some Class 1 lasers, which have no hazard, come in sizes large and small. So, size does not matter when it comes to a laser. Lasers do not pose the same health risk as X-rays and other ionizing radiation sources. This is a fact. Sometimes the scientific language for lasers can be confusing, so let's make use of a basic overview as to why this is so. There are two types of radiation: ionizing and non-ionizing. Ionizing radiation is the dangerous atomic fallout sort, stripping electrons from atoms, breaking chemical bonds in your body, and sometimes causing catastrophic destruction to your DNA. Non-ionizing radiation has no similarity to ionizing. It does not strip electrons from atoms, but it does stir them up, which releases heat. But these electrons will return to their normal state and produce only minimal damage. They're incapable of injuring people unless directly contacting the skin or eyes. Lasers emit non-ionizing radiation. Therefore, laser hazards are very different from those of ionizing sources like nuclear material and X-rays. Many radioactive sources emit potentially harmful ionizing radiation in all directions. Consequently, radioactive sources are often stored in special storage containers to protect personnel from their potential harmful effects. And radioactive sources, like nuclear material, if directly contacted, are capable of causing contamination. Individuals will continue to be exposed to ionizing radiation until the material has been removed through decontamination and radioactive waste disposal. The health effects from ionizing radiation will vary depending on the level of exposure, but the cumulative effects can be devastating. When compared to ionizing material, a laser poses no threat by simply being near personnel. Lasers require an external power source before they're even capable of emitting non-ionizing radiation. And a laser cannot emit non-ionizing radiation until it's been electrically powered up, turned on, and fired. The non-ionizing radiation of lasers travels directionally in straight lines. Therefore, the hazards are very directional and only exist along the beam path. For any potential laser overexposure to occur, you'd have to be in the beam. But if reflected off a surface, a laser is still capable of producing injury. The eyes and skin are most susceptible, the eye being the most sensitive, while the skin is usually vulnerable only to higher-powered lasers. In most situations, hazards from laser radiation are not cumulative, though there are cases of effects from exposure to blue or UV wavelength lasers. But all non-ionizing emitting devices, including lasers, are incapable of causing any type of radioactive contamination. So there's no need to be afraid of a laser because it's in your vicinity or simply turned on. So look out for myths, in particular these, but also this.
Have you ever stared at the sun?
No, Sergeant.
Why not?
Because it'll blind me, Sergeant.
What's wrong? I thought this can't hurt you. You don't want to look at it?
No, Sergeant, I don't want to look at it.
It bears repeating. Never let anyone lead you to believe that looking into a laser's exit aperture is safe. Maybe the laser you hold isn't harmful. Maybe it's Class 1, and therefore incapable of causing an injury. But then again, maybe it's not. And if the laser you're holding was not developed and tested by a recognized office within the DoD, or if it was purchased via the internet, then there is no guarantee that the classification is accurate at all.
Look at it! Look at it! Stand still! Look at it! Keep your eyes open! Stand still! Look at it! Look at it! Look at it! That's right. You don't want to look at this laser. This laser is the sun to your eyes. It will burn the retina off the back of your eye socket. It is the sun. Is that understood?
Yes, Sergeant.
So, do you really want to risk your eyesight or that of your fellow soldiers by exposing them to the laser you hold? No, you don't.
All right then. Put these lasers away and leave the Star Wars crap for Hollywood.
So treat your laser like a weapon. Never point it at anyone or anything it was not meant for. Your behavior is the first and oftentimes the only line of defense from injury. So, the next time you hear someone dismiss the hazards associated with these little green and red lights, give them a grin and simply ask, "So, you think you know lasers, huh?"